Good afternoon, everybody. I will provide you with a less technical presentation and give you a little bit more insight in trying to build an ecosystem in photonic chip technology and integrated photonics, which we believe is a new era of semiconductors. And I think the global megatrends, everybody's been familiar. I've heard it every day when you arrive here in Taiwan, and every show you go, with the cloud, with the infrastructure, with the AI, of course, intelligent edge, and also the gaming and visualization. A lot of things are happening, and of course, with the introduction of the language models, ChatGPT, it became also accessible for people, people that are using this technology, but you have a massive growth in data. And at the same time, you see the Moore's law is challenging for the future. And this is really interesting if you look at it. I think Microsoft already announced that they're going to build a nuclear power plant next to their future data center. You know, if you look at today's economy and the power consumption that data is asking, we already are at the power consumption of a country as Germany. You know, by 2030, which is in 5 years, it's already the power consumption of India. So this is not sustainable. So energy will be the major bottleneck for the semiconductor industry, but also basically for our society. So we need to come up with certain solutions. So one of these solutions is integrated photonics or photonic chip technology. So you integrate multiple photonic functions, I like the electronic ICs, but this time you do it with photons. And of course, it's about high-speed data transmission, but it's also about the reduced power consumption, the reduced signal loss and interference. We do believe it's scalable to high volumes at low cost, but that's a process we're still into. You can make compact, scalable designs, and the multiple optical components on a chip. So, for example, in the healthcare, you will see in the future with the point of care, you have functions in a device that nowadays takes a full room, and in the future will be in a handheld device. So we really believe integrated photonics can revolutionize markets. And of course, here in Taiwan, we talk about silicon photonics and all the aspects it has, also here for the semiconductors and the power and compound semiconductors. But it has more applications. And so I like to broaden your view a little bit on what it could do and which applications you could see in the future that in the end will also touch your life. Of course, we have the datacom and the telecom, but you also see quantum. In Europe, we now are running pilot lines, photonics for quantum, where photonic technology will be used for the quantum computing. Mobility, autonomous driving, LiDAR, which was suspected already to be a mass market maybe by today. There is a delay, but we do see changes again, also in Europe, in the European automotive industry, that LiDAR is back on track and getting into new interest of developing this technology further for cars, but also for robots, or maybe also for a logistics center. The healthcare already mentioned with the point of care systems, agri-food, sustainable farming. I really believe that if we can make the chips in the future on the sensing side up to 10, 20 euro cents or 20 cents, then in the future in the supermarket, a chip will tell you if a product is still fresh instead of a date that's printed on it. But also precision agriculture. One thing I didn't mention, but what we see, especially in Europe, I think everybody heard about NATO, the compromise. So Trump is pushing the European countries to speed up or to increase the budget for R&D, especially on the defense side. So we see GDP spending at this moment in the Netherlands, for example, is at 2% on defense. That needs to grow to 5%. So 1.5% can be used to invest in infrastructure, for example, but to get from 2 to 3.5%, a lot of funding will be there for innovation. And many of the applications that you see also have an application for defense. So I think like DARPA in the United States has been a key driver for the semiconductor industry. I think defense in Europe will be a key driver also for the integrated photonics industry in the coming 5 to 10 years. Today, it's very simple. We take 0.1% of the total revenue in the semiconductor market. And this is expected to grow to 3% in 2030 and 5% in 2035. When the whole idea for the integrated photonics and building an ecosystem 10 years ago, people said, it's going to be big, it's going to be replaced. It's not going to replace, it's going to add functionalities in the semiconductor markets, making drives for new applications. So, if you see what's happening today, these are just some headlines from, let's say, the past 6 months. Of course, the announcement of NVIDIA with TSMC for the co-packaged optics is a big game changer in the datacom. You also see in Europe, STMicroelectronics is stepping in, Global Foundries, Nokia acquiring Infinera. But it's also interesting that at the same time, in the United States, they're also looking into, hey, what's happening for photonic chip technology in the datacom? It's new technology, but to make a photonic chip, for example, in the Netherlands, we use, we have ASML, but we can use a machine that's 20 years old to make the waveguides on the chip. And the waveguides go to 80 nanometers and not below. So you can use the machines that are 20 years old. So the machine to build a photonic chip, they're all there, but making the photonic chip is still sometimes challenging also in the process. So what you also see in phases with this new technology or the new industry, we're going through phases which are similar to the semiconductor industry. And I think we're on the verge between phase 2 and phase 3. So first the integrated device manufacturer, then you see EDA tools, manufacturing tools, fabless designers, independent foundries, and now you see that you get specialization in the manufacturing tools, in the EDA, but also in the foundries, especially also in the packaging, where for integrated photonics still is the main challenge. If you look to the total cost for a photonic chip, 80% is still in the packaging at this moment, which is 20% in an electronic IC. And there's more than silicon photonics. I do believe silicon photonics is most known and serves also as, let's say, an overall, let's say, term for integrated photonics. But in the Netherlands, we have a major strength in indium phosphide and silicon nitride. And we do believe that these materials each have their unique application for the future. At this moment, silicon photonics is key in datacom, but indium phosphide can also do something there. But for example, silicon nitride is considered for quantum computing the really best material at this moment. But with the functionalities you see also with the different applications, the materials will find their way in the market. And of course, getting them together would be the ideal solution. And a lot of programs are working on this, whether it's a microtransfer printing project that's also running in Europe, and there's also about laser shooting materials or working with different interposers. This is still a world to discover, and many organizations are working on this. How you can combine these different materials, let's say, in one platform. If we can find a smart way to do that, then more markets will open, and the integration of integrated photonics in, let's say, consumer products as well will go a lot faster as well. So we really believe, and this is a picture from 5 years ago, the system of the future will consist of multiple technologies. Now, the history of integrated photonics in Eindhoven, or in the Netherlands, where it all started, and also, like many things have started in the Netherlands, it all started with Philips. Unfortunately, Philips today is not, let's say, the big company it once used to be, but it's been the father of many successful companies. Philips stood at the base of TSMC. Philips stood at the base of NXP or Signify, and also is the founder of ASML. So they have a rich heritage in Eindhoven, within the world, with world-class companies in different markets that they work. So what you see in the mid of the 90s, that was when the first research already started. So can we use photons on a chip, on a semiconductor? These facilities have been built, research been done, and Smart Photonics was the first company to be coming from the university in 2012, trying to build an independent foundry on indium phosphide, a pure play foundry. And in that process, the first companies started, and also PhotonDelta, which I represent, was started in 2018 with public funding, trying to provide, in the beginning, equity to startups, mainly coming from these universities. And right now we're running a program, National Growth Fund program, which is more than 1 billion euros that's being invested in the Dutch ecosystem. So we've been established in 2018. We have about 30 people working for us. And like I said, we're the executor of the National Growth Fund in the Netherlands, which started on the 1st of January 2023. So in total, we put 470 million euros public funding in the market, supporting the startup companies, innovation projects. We help them with internationalization. We also do a talent attraction program, and we are working on road mapping. What are the market technology trends? How does it develop to the future? And if we look to our own ecosystem, do we need to change things? In which companies we want to initiate to start or to fund? Any innovation projects we can fund. The 470 million is also matched with 630 million private funding. For example, in innovation projects, we can only do a maximum up to 50% subsidy in the innovation project if it's a company related. And also if we do, we provide loans nowadays to companies at Euribor interest tariff, which is a very low tariff with 18 months postponed payment. We also ask private equity to step in. So coming back from 2018, when the first plan was for photonics, it was a broader plan to the 1.1 billion, and of course you also have the European Chips Act. I believe this morning was said 80 billion euros Europe has invested in the semiconductor industry from the European Chips Act, but I have to say that 90% of that funding comes from member states. So the state aid rules have been, let's say, relieved, and it's the member states that fund like building these fabs. It's only 5 billion euros that's been used to build pilot lines. And there's been 5 pilot lines. One is, for example, for IMEC, for the 2 sub-nanometer pilot line, but there's also a pilot line for integrated photonics, which in the Netherlands we're going to build a new fab for indium phosphide on 6-inch. That construction will start in January, and we hope to have it opened 1.5 years later. So what we're trying to do with the Growth Fund. So on the one side, which is, let's say, PhotonDelta as an organization, is providing services, let's say, towards the ecosystem or towards the outside, the ecosystem development. And the other 2 pillars are really the innovation projects, building the application, supporting the application technology for design library, the PDKs to be developed, in this case, at the foundries. And also the industrialization and scaling on the integration, process optimization, and scalability. So this is historical public and private figures that has been put in the Netherlands ecosystem. So from 2016 to 2024, it's 500, close to 600 million, where the last part is also a big contribution from the EU. And if I look to the next 3 years, we now have a program running for the next 200 million euros that we can invest from the 1st of January 2026 to the 31st of December 2008. We will put another 200 million in. But CHIPS Act will come as well, and we already know that CHIPS Act 2.0 will probably be double the budget. So from 5 billion, it will go to 10 billion, and it will be connected also to the pilot lines. So we're working in the European Commission on what we can do to mature, let's say, the value chain in integrated photonics in Europe. So this is an overview of portfolio, and I put it here so you can see the different applications of companies that we can fund. So in the health, it's on biosensing, but also fiber grading. And Mazak has a technology that if you would insert 10cc cold fluid on one side, on the other side they can measure it, and by measuring it from non-invasive, they can measure the heart condition. The killer app is that they can do the measurement as such that in the future, and that's where they're quite far now, they can measure how much blood there still is in the body. So right now, if somebody's being operated, it's always a guess how much blood somebody has lost. Too much blood is not good. Not enough blood is also not good. And with a photonic sensor, you could sense how much blood is still in the body, so you can know what you have to do. As a quick example, but also in the aquafood, Spectric. We have a big problem of nitrogen, methane. They all have a wavelength, so you can measure that with the gas sensing. Of course, we have the fabrication and packaging, also in AR, VR. Of course, in datacom. And you see, especially on the application side, more and more companies. So if you look to our ecosystem in the Netherlands, we have the whole value chain. So from design to foundry, testing, packaging, and the application side, it's all there. And I'll be honest, we're great at prototyping, and now we need to become great at manufacturing. But to be great at manufacturing, we need partnerships as well. And I think that's also why we're here in Taiwan, to see how we can join each other's forces of the skills that also you have on mass manufacturing, the skills that we have on the fundamental applied research, and coming up with a solution and how to get it faster in the market, and also solve some of the bottlenecks challenges that there still are, especially in the packaging and testing side. And of course, what we see, especially in the last 6 months, a lot of companies from the semiconductor industry, from the back end and the front end, are stepping into integrated photonics, trying to see where they can offer services with their products. ASML is a good example. Up to 6 months ago, we were not that interesting, and in the past 3 months, we already had 4 or 5 conversations with them. So what's happening? They want to understand what's happening. They want to see how they can also contribute in building the integrated photonics ecosystem and value chain. But also in testing and packaging, we see new entries. Now, if you look to, so why we're here, what is the purpose of then an organization like PhotonDelta? And, like in Singapore, you have also the Economic Development Board, and you have several organizations in Taiwan where you try to stimulate economic development. In this case, if you look to the raw photonics and PhotonDelta, this is an example. This is what I would sketch would be the current situation, where green would be, it's good, yellow can be better, and orange is like really needs attention. So what we try to do as PhotonDelta, and then see how we can solve these bottlenecks, and by startup and scale-up financing, arranging that, which is also Europe is stepping in as well. For the market development, organizing straight and innovation missions to meet companies, institutes in foreign countries to seek the collaboration, to find the win-win. But it's also, in this case, developing a pilot factory and development facility, arranging that the infrastructure is at the right scale, with the right tools. Venture building. We see a lot of companies, tech-driven, but need to transfer into commercial-driven. How are you going to do that? Are you going to keep on building your product better and better, or are you going to work with your customer, and with your customer make the product better and better? And talent attraction, which I think all over the world is a challenge. And of course, the national and international network. So if you look to the second phase of a national growth fund, from the lessons we learned in the past 3 years from phase 1, where we put 360 million euros in the market, we said we want to go for 4 technology domains, which is in imaging, sensing, wireless, communication, compute, and we created missions. And these missions is where we want to have partners getting together, so it can be a combination of companies, research institutes, universities, trying to get this from TRL level 4 to 5 up to 7 and 8. And hopefully by the end of, let's say, 2028, we can get the first prototypes in the market, or we can get design-ins, or we can already get commercial revenue on these missions. And of course, the manufacturing infrastructure is something that public funding will be needed. You know, we're still in the pre-competitive phase of this integrated photonics, so public funding is needed to get it on a maturity level. I dare to say that on integrated photonics, we have a very big cluster. The 2 locations in the Netherlands, both originate from universities, University of Twente and the University of Eindhoven, where really our industry kicked off, and where you see on the infrastructure, on the manufacturing, on the research, on the universities, and on the companies, the application side, basically 80–90% of all the companies are connected to these universities. And that's also how we look international. Is there a university working on fundamental research on the integrated photonics? Is there a research institute bringing it to application? And are the companies, foundry or big company, supporting it? For us to make connections to see where we can build new networks. And PhotonDelta is, let's say, the only dedicated cluster organization in Europe, or dedicated on European, on the PIC technology. Most of it are in optics and photonics. But if you look to Europe as well, the complete value chain is there. Europe is very strong on fundamental research by the universities, getting it to applied. We struggle at times making it a commercial success and building great companies. What you see that there's a lot of funding now for pilot lines, getting the infrastructure ready, and now we need to tackle the bottlenecks in the value chain. But the foundries are there. ST Microelectronics is also stepping in on 300mm silicon photonics, and all key ingredients are there. But we need to fasten up, and these are just lessons learned from Europe. The Draghi report, the general concerns, it's about getting access to capital. It's also the legislation, different countries, different rules on VAT, taxes, labor law, you name it. But also incentives for scaling up, you know, dare to choose. You know, don't give every country the same, but if you have a center of excellence, make them even better. You know, go with the champions and do not create competition internally, which we've also done in the past. And strengthen the EU by looking also at the critical mass, a dedicated program for the EU industry. So make it dedicated on photonic chip technology, also make something dedicated on semiconductors, and accelerate. There's a change. Adaptation is adaptation. So we see conservative companies in Europe, let's say for the automotive industry, to look into new technology and stepping in. And I think we also need to accelerate this. And this is something that we need to sit down and get it better, I would say, and therefore more competitive. And last, this is my 3rd visit as CEO of PhotonDelta. I've been visiting Taiwan since 2002. Many times I've been here, always trying to build bridges between Europe, the Netherlands, and Taiwan. The Netherlands, 1 and 2 Taiwanese companies, when they start in Europe, starts in the Netherlands with a sales and logistics center. And over time, you see product development, assembly, manufacturing, and even R&D getting there. Just go back. So what I wanted to end with is the PIC Summit. It's the largest integrated photonics event in Europe. I'll leave it. It's on the 4th and 5th of November. We already built, we signed MOUs with HISPA and TOSHA, so HISPA Heterogeneous Integration Silicon Photonics Alliance, I believe, and TOSHA is the Taiwan Optoelectronics Semiconductor Industry Association. We came here with innovation missions, and now there's a Taiwanese mission also coming to the PIC Summit Europe. I believe we already have 30 people registered. There will also be keynote speaks at the PIC Summit. Scaling up together in dynamic world is, you know, we have to do things together. Don't do it alone. Let's join forces and try to bring this technology faster to the market and also make your lives better. So thank you very much.
Now it's open for discussion. Any questions? So I don't, Barry, please.
So I think the function of your organization is more like a government-funded agency to foster the growth of the PIC industry in Netherlands.
Yes.
Is that all? So how we can participate in Taiwan?
It's several ways. You know, I think if you look to the bottlenecks that we still see in the value chain, you know, if we don't have technology, if we don't have that solution, and a Taiwanese company would have, we can join forces. We funded a project between the packaging company Fix and E3 to look for a certain solution on the packaging and the connection of the fiber to the package. We're looking at the foundry level, either be a supplier, customer, but also maybe also to better understand how we can control the process, how we can do the testing and measurement better. So, you know, companies in that direction with, and design, of course, as well. So I think on several ways, I think we're complementary. You know, our strength is in indium phosphide, silicon nitride, strength is in silicon photonics, and there's still many challenges to overcome. And let's say, if you look to the equipment, how to make it work and solve the issues on the packaging, which packaging is still semi-automatic. Testing as well, you know, you need to test every chip. So we've still a lot of things to overcome. So, you know, and projects are being funded, innovation projects, we also fund those to solve this issue, and IMEC is also heavily involved. And also on the European level, there will be more European calls trying to solve these bottlenecks that we see in the value chain, which are also open to outsiders. You might need to have a legal entity in Europe, but then it doesn't matter where that entity is.